Okay. Let me, give me a second, guys. I'm gonna try to, just get some examples. Hopefully I can find some online. So basically in this live stream, what we're gonna do is we're gonna go ahead and do, I want to say quadratic inequalities and also rational inequalities, because I feel like if, I did do a video over this stuff, but at the same time, I don't want to, I didn't want to upload it because it's really long, and I think that it's just a lot easier if I just do a live stream. And that way, for those of you that are, that do want to watch it, y'all can watch it. So, basically, let me just kind of look for some examples. So, I'm gonna try and, because I know I definitely did do a certain example that was very difficult, and I'm gonna go back and just look at that particular example that I did. Thing is, I cannot remember exactly what the example was. If you guys could give me a second, and I'm gonna look for it really quick. And also, I'm gonna change this to live chats that way. Okay, so let me see. Give me a second, guys. I'm gonna look for the example that I was wanting to do. So don't know if it has to be around here somewhere. The thing is, guys, I have so much paper that sometimes I'm not a very organized person. Okay, so we're just gonna do an example that I wanted to do. Also, actually, I'm gonna look in so I'm gonna do an example that I did upload on YouTube, and I'm also gonna do another example with rational inequalities where I literally I went ahead and I went ahead and did on YouTube, as well as the one that I did on, as well as the one that I did that was a lot harder. And I'm also going to do quadratic inequalities in this live stream. So give me a second, guys. I'm gonna look for okay, so give me just a second. I just want to make sure that the live stream is working. Okay. So the example that I wanted to go over was it was the following, and let me just write this, let me just type it down. So it was solve, actually let me go ahead and change the font here. So solve rational inequality, and it was the following, and again, I've done this problem in a video, but I'm going to do it in a live stream so that those of you that do ever, if you do ever watch it, you guys can see exactly what I'm doing here. So it was x minus 1, so it was x minus 1 over x minus 3 is less than or equal to 0. And that was the inequality that we are basically looking at, right? And so I want to I want to go over this because I do think it's very important. And yeah, so basically what I'm gonna go ahead and do here. So this is the inequality itself, and we're asked to solve this inequality, right? And we want to know what the solution set would be. And obviously, and actually, guys, give me 1 second. I'm sorry. I'm gonna go ahead and get my charger for my phone because I want to make sure that the stream is running smoothly, and usually I use my phone to play the video. So in the past couple of videos that we've done, or that I've uploaded, we have gone over rational inequalities as well as you know, some other stuff, and I want to particularly go over rational inequalities in this live stream, as well as just quadratic inequalities as well, might as well, to show you guys how to do them. And I didn't want to make a video because these are really long, so might as well do it in a live stream. So let me just go ahead and do this, and I'm gonna just go ahead and do this, and okay. So obviously we want to solve this for x, and the way that we're gonna do this is we're gonna go ahead and we want to list our restrictions, right? Now, obviously, it says less than or equal to 0. And this basically becomes, you know, just, it basically, we need to know when it's less than or equal to 0. So the first thing that I'm going to do here is I'm going to state my restrictions. So number 1, state restrictions, right? And so to do that, basically what you have to do is you have to state where the inequality cannot be equal to 0. So particularly, so where x cannot be equal to 0, or where the inequality itself cannot be equal to 0, right? Usually in this you know, if you have it of the form like, say, a over b, and you want to state where b cannot be equal to 0, right? So that's basically what I'm trying to say here. And that's exactly what we did in the video. We stated what the restrictions were. And so here, the denominator, we have x minus 3. Now we're going to go ahead and set that not equal to 0. And we add 3 to both sides. We solve for x, and we have x cannot be equal to 3. So we know that for a fact that is not going to be included in our interval when we actually go over inequalities, right? Or when we actually do the problem, we know for a fact that 3 is not going to be included in the interval because it's a restriction. If I literally put 3 as a value for this, I end up with 3 minus 1 over 3 minus 3, and then less than or equal to 0. This becomes 2 over 0, which is undefined, so I know for a fact that 3 will not be included in the interval. Excuse me. So that is kind of the first thing that you're going to do here. The other thing is you want to make sure and state your, so also state x-intercepts. Okay. So the x-intercepts basically are where you make this following equation or this following expression equal to 0. So you know x minus 1 over x minus 3 is equal to 0. Basically, that's what you do. So set expression equal to 0. Okay. So we're going to go ahead and do that. So when we set it equal to 0 and we solve for x, and solve for x, right? So when we do that, this becomes x minus 1 equals 0, and we're going to add 1 to both sides, and we know that x equals 1. So again, we know for a fact that 1 will be one of the numbers that we're going to be using, and that it will be included in the interval. So 1 will be included in the interval. And the reason why I say that is because it's less than or equal to 0. If it was just less than, then I would not even be including. So like only list x-intercepts when expression is less than or equal to 0 or greater than or equal to 0. Do not list them when it's less than or greater than 0, because you don't really need that in that case. And we're going to go over one that, obviously I'm going to make this one, I'm going to do the same problem, but I'm going to show you guys exactly what I'm talking about. So we're going to list our x-intercepts here. And like I said, these are our x-intercepts, and the restrictions here are x cannot equal to 3. So we know that if we draw a number line, so again, restriction, I'm just going to rewrite restrictions, x cannot be equal to 3, x-intercepts our x is equal to 1, right? So when I draw my number line, and let me just kind of change the view here, I end up with something like this. And I'm going to go ahead and do, so I know that 1 and 3 have to be on the number line, but it doesn't mean that they're included. It just means, you know, they're on the number line, right? Obviously. So I can go from negative, let's say negative 4 to 4, or let's say negative 5 to 5, right? So a negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, right? And obviously, like I said, we're gonna go ahead and we're gonna go ahead and do this here. And like I said, the restrictions are x cannot equal to 3. When there's a restriction, it means that that number is not included in the interval. Now, obviously, when a number is not included in the interval, there's a parentheses there, meaning that there's a hole. There's a hole or like an open circle, right? So I'm going to put at x equals 3, I'm going to put at 3, there's going to be this kind of like a open circle here. And the x-intercepts, like I said, are only x equals 1. So I'm going to put a closed dot here because a closed dot represents this. So if you guys don't understand what this means, I recommend that you go a little backwards, like go back a few and try to understand what they mean when they say write the interval in interval notation, and understand what it means when there's a bracket or parentheses, a open circle or a closed circle, right? So this is not included in the interval and this is included, obviously. And again, guys, I'm going over this because this is mostly for terminology reasons. In the original problems, I do not go over this because it would take forever. Excuse me. So, hence why I'm just taking my time to teach you guys this. This is the longer method of kind of analyzing these kind of problems, because this gives me an opportunity to explain with more context. So, this is, you know, obviously the restrictions are x equals 3, x cannot equal to 3, right? And the how do I say it? The x-intercepts are just x equals 1. So now the idea here is we want to go from, you want to list the values at which you're going to do your test intervals. We have one from negative infinity to 1 because we need to test those intervals to see where is it greater than 0, where is it less than 0 or equal to 0, right? Obviously at 1, like I said, that is why we did the x-intercept, because we needed to know where it's included in the interval because of that equal to sign, that greater than or equal to. Oh, and by the way, I forgot to do something here. Hold on. I literally forgot to do something. Give me a second, guys. I literally forgot to do that. There we go. I don't know why. There we go. I should have done that from the very beginning. I don't know why. Yeah, I should have put both. My bad. I changed the title. So, give me a second. So, basically, here, we're going to do from negative infinity to negative 1, or I'm sorry, to 1 bracket. And we're going to also, so that's one of the intervals that we're testing. The other interval will be from 1 to 3, right? So this is the other interval. And you make sure you put a bracket at 1, so 1 to 3, and then parentheses at 3, because there's an open circle there. So that's the other one. And then the other one is going to be from 3 to infinity, which is, just show you guys, it's going to be this part. So here's positive infinity, and that's negative. Here's negative infinity, right? Doesn't matter where you put it, as long as you know that that is where positive infinity would go. Now, this is obviously, like I said, 3 to infinity. And this is the problem, or the part, right? So those are our test intervals. Now, obviously, I'm going to rewrite my expression, right? X minus 1 over x minus 3. Oops. X minus 1 over x minus 3 is less than or equal to 0. So let me just explain. So now all you have to do here is, a lot of people and a lot of teachers, they make charts. They like to make charts over, you know, over what the like, they like to make these kind of tables where they say, well, this is the interval that we're testing. We're going to pick an x value. We're going to do the test, or the evaluate, slash, so that's, let me cut and write it in my, I'm going to try to write in the best handwriting as possible. Test slash evaluate slash plug in. And then I like to put the fourth column as positive or negative, right? And once you know, obviously we would say at the very end, well, if it's less than or equal to 0, that tells you that it's going to be negative, or it's going to be equal to 0. I like to do positive or negative here. And then once I'm finished with this, I say, well, where is it going to be negative? Depending on what my inequality would be, right? So here we do from, so like I said, there's from negative infinity to 1. So parentheses negative infinity to 1, and then close bracket. I do not need to do x equals 1. That is exactly why we did the restrictions as well as the x-intercepts, because you don't want to waste your time trying to plug in 1 if it's included or if it's not included, etc. You don't want to do that. So the idea is to just, that's why we stated our restrictions as well as our x-intercepts. So now we're going to pick an x value that is less than 1. So we can pick x equals 0. Actually, I don't want to do that one because I don't want to confuse you guys. I'm going to pick a negative number, and I'm going to pick x equals negative 2. I'll do x equals negative 2. I don't want to confuse anybody by picking x equals 0, because then if I pick x equals 0, y'all are going to think that I'm talking about this, part, and this is not, I don't want to confuse anybody. I'm going to pick x equals -2. So just, you know, if you guys don't understand the difference, like what I'm trying to say is that just because I'm picking x equals 0, it has nothing to do with the less than or equal to 0 part. This 0 here has nothing to do with the x equals 0. If I do pick x equals 0, that has nothing to do with it. X equals 0, in reality, this one is really y. But again, I don't want to confuse anybody. If that confuses you, just pick a number that satisfies this inequality. Do not pick x equals 0 if that confuses you. So I'm going to pick x equals -2. So when I do that, and again, I'm going to just kind of do x minus 1 over x minus 3 less than or equal to 0, right? And when I do that, I end up with the following, and I'm going to say, I pick x equals -2, so I'm going to do -2 minus 1 over -2 minus 3 less than or equal to 0. I get -3 over -5 less than or equal to 0. Do not change or switch the inequality, because yes, we're dividing here by a negative number, but there's nothing going on the right side. So really, this is going to be 3/5 less than or equal to 0. Now again, so what I'm going to do here is, actually, I'm going to change this, and I'm going to put yes or no. Does this satisfy this inequality? Is 3/5 less than or equal to 0? Obviously, it's not. No, it's not. So from that, I know for a fact that this interval is not going to work. So no, this will not work, right? And I'm going over this as slowly as I can for those of you that, you know, I'm going at a good pace, I hope. This is why it's a live stream and not really a video, because with a video, I go over it faster. With a live stream, I try to go over it in more detail and more slowly. So then, hold on. So now we're gonna, so that was from -infinity to 1. So now we're gonna do from 1 to 3. That's the next one that we're testing. And always pick a number between the two things, especially if you already listed your restrictions as well as your x-intercepts. So we're gonna pick x equals 2 here. And when I do that, again, I'm gonna, you know, this is the inequality. I'm just gonna do 2 minus 1. So let me just kind of rewrite it so that you guys know what I'm doing. X minus 1 over x minus 3 less than or equal to 0. So I'm basically going to plug in x equals 2. So 2 minus 1 over 2 minus 3 is less than or equal to 0. This becomes 1 over -1. It's less than or equal to 0. -1 is less than or equal to 0. Obviously, this works. This obviously works. So, yes, this works, right? So we can circle it. This works. Check it, do whatever you want. Like, you know, as long as you know that it is satisfied, right? And now, the other one we're going to do, and I think this is the last part, the last, kind of the last interval, which is 3 to infinity. So the last one would be 3 to infinity. And again, you want to pick an x value that's greater than 3. So we're gonna do x equals 4 in this case. So if I do x equals 4, and again, I'm gonna just rewrite my expression so that you guys know what I'm doing. X minus 1 over x minus 3. Give me a second. It's less than or equal to 0. This becomes 4 minus 1, not 3. 4 minus 1 over 4 minus 3. It's less than or equal to 0. This becomes 3 over 1, less than or equal to 0. Just 3 less than or equal to 0. This does not work. So no, does not work. So what is our solution set then? If I know for a fact that this does not work because we just did it over here, that's basically what this one was. And we already know that the green one didn't work, it was this one, right? The green one, the highlighted green one did not work either. So no, this one doesn't work. So the only one that works is from 1 to 3. And that is how you know that that is your solution. So the solution set is from 1 to 3. With rational inequalities, guys, I want to make this very clear. With rational inequalities, you're going to have a solution set. It's either that or you're going to have no solution, or maybe all real solutions. It just depends. And sometimes there's going to be a union. So, let's see here. So that is how you do that one. And now we're going to go over a way more complicated one than we did. And I did not upload this on YouTube. So I'm going to write this down and I'm going to show you guys how to do it. The good thing about this inequality, so now we're going to do another one. And let me kind of just... And I hate that it changes back to Calibri. Should stay on... I don't know how to change it to so that I can stay on Cambria. I need to look at my settings. Solve the rational inequality. And this one... Oh, and also... Sometimes they say state your answer in interval notation, use the union symbol. And I'll just put I'll insert kind of a symbol here. Should be in here, hold on. I don't see it. It's the little union symbol. If necessary. Okay. So I always like to word my problems this way. And the problem that we're gonna do is a lot harder, but the good thing about this problem is that the quadratics that are on top and bottom are already factored, so we don't need to factor anything here. Whereas sometimes in algebra, they're gonna give you problems where you do need a factor. X plus 2. And let me do it this way. Hold on. Actually, no, this is good. So x plus 2 times... I was going to take off the parentheses, but no, I can't do that. Because they're being multiplied. Excuse me. Sorry about that. So, let's see here. Oh, and this is going to be greater than or equal to 0. So, in this problem, we have this stuff going on. Now, again, we're going to do it kind of the same way that we were doing the previous problem, where I went ahead and I went ahead and just, you know, stated the restrictions and the how do you call it? Like the restrictions and the roots, or the zeros, right? So, or the x-intercepts, as I called them. So, like I said, you're gonna, number 1, state x-intercepts and restrictions. And when I mean restrictions, I mean like in the denominator, if there's an x term on there, those are going to be your restrictions when you set them equal to 0. So the first part we're going to do is our x-intercepts. So let's go ahead and do that. And of course, this is where when you say x, when x is, you know, make y equal to 0, so basically make the expression equal to 0. So we have x minus 1 times x plus 8 over x plus 2 times x plus 1 equals 0. Now, you want to solve for x. So you want to go ahead and solve for x here. And the way that we're going to do that is we need to multiply times x plus 2 times x plus 1 here. So on top and bottom, or on both sides, not top and bottom, on both sides of the equation, right, to get rid of that fraction. So this cancels out. We end up with x minus 1 times x plus 8 is equal to, and obviously 0 times anything is 0. Right, so then the next thing you're going to do is use what is called the zero product property. If you guys don't know what the zero product property is, that's why we're in this stream. If x minus a, let me do plus or minus, x plus or minus a times x plus or minus b equals 0, then x plus or minus a equals 0, or x plus or minus b equals 0. Basically, you're making both equal to 0. So here we have x minus 1 times x plus 8. Obviously, we're going to make this equal to 0, so x minus 1 equals 0, or x plus 8 is equal to 0, right? Now, here, we're just going to add a 1 on both sides, so this becomes x equals 1. And here, we're going to subtract 8 on both sides, and this becomes x equals negative 8. So those are my x-intercepts for this, you know, this problem. And now we're going to state our restrictions. So now the restrictions are something else, and now the restrictions are where x cannot be equal to 0. So we have x minus 1. So So where y cannot be equal to 0, or x, not x cannot be equal to 0, but like when you set the equation not equal to 0, right? I really hope that makes sense, guys. I'm really trying. Basically, you're just going to make the expression not equal to 0. That's all I'm saying here. So I don't want to say where x cannot be equal to 0 because that's not right. If that confused you, I do apologize. I meant where the expression cannot be equal to 0. So where expression cannot equal 0. Okay. So we have x minus 1 times x plus 8. Actually, guys, oh my goodness gracious. I'm wrong. It's not where the expression cannot equal 0. Okay, it's where the denominator cannot equal 0. So what I'm saying by restriction, when I tell you list the restrictions, just set the x values here not equal to 0. It's like if I say y equals 1 over x, state the restrictions. Well, x cannot be equal to 0. If I say 1 over x minus 1, state the restrictions. X minus 1 cannot be equal to 0. It's where the denominator, in terms of x, cannot equal 0. In terms of x, cannot cannot equal 0. Okay, I just want to make that very clear. Now, the restrictions here, we obviously have x plus 2 times x plus 1. So I can obviously this cannot equal 0. Means that x plus 2 cannot equal 0, or x plus 1 cannot equal 0. Subtracting 2 here on both sides, we get x cannot equal negative 2. And subtracting 1 on both sides here, we get x cannot equal to negative 1. So these are my restrictions, right? And the x-intercepts are, so let's go ahead and now list them. So the x-intercepts are the following. X is equal to 1, x equals negative 8, and like I said, the restrictions where x cannot be, where the expression on the bottom x cannot be equal to negative 2. And you can always test it out. If you plug in negative 2 here, you're going to get undefined. Where is the expression undefined? Those are your restrictions. Restrictions are where the expression is undefined. Okay. So we have x cannot equal to negative 2, x cannot equal to negative 1. And now we're going to draw our number line. So the x-intercepts are 1 and negative 8. So let's kind of do let's go from least to greatest. So negative 8 is the lowest. So here's negative 8. We go then to negative 2. And then we go then to negative 1. And then we go to 1. So the x-intercepts are 1 and negative 8. So we can kind of put those as they are included in the interval. So 1 and negative 8 are included in the interval. And negative 2 and negative 1 are not. So now you want to state the different parts. So you want to split it up into parts. So now this becomes one part, right? And like I said, here's negative infinity, and here's positive infinity. And you want to go ahead and do from there to there, and then you have from negative 8 to negative 2, and then you have from negative 2 to negative 1, and then you have from, let me do it this way, negative 1 to 1, and then finally you have it from, do it this way, 1 to infinity. So let me write those down. We obviously know that the intervals are the following. So the interval, let's do negative infinity to negative 8, and obviously negative 8 is included. The parentheses goes at negative infinity, right? And then, you know, obviously, so that's the interval for that, right? And then it goes from negative 8 to negative 2, so I'll put the interval and then the test x value, and then the calculation, and then I'll put does this satisfy the inequality. This stuff that I'm doing here is exactly the same way I did it the other way. I guess I'm wording it differently. I put yes or no here. That's the same thing. I'm just, you know, basically, does it satisfy the inequality? Yes or no, right? So here we have from negative infinity to negative 8. And we're going to test a value that is between those two. So let's do x equals negative 9. And the calculation, obviously, you know, we would kind of do, and let me kind of let me kind of put this more over here. And let me kind of make this a little longer. And let me put this line a little more over here. So when we do evaluate it, I'm going to write my expression, the original expression. So we have x minus 1 times x plus 8 over x plus 2 times x plus 1, x plus 2 times x plus 1. And I'm going to calculate x equals negative 9. So I have negative 9 minus 1 times negative 9 plus 8 over negative 9 plus 2. You always want to make sure you put a value that is in between the interval, right? That is in this interval. Obviously, it goes from negative infinity to negative 8. So I can go x equals negative 9, obviously. So that's the one that I picked. But you can pick x equals negative 10, etc. Right? So then when we evaluate this, we get negative 10 times negative 1 over, and obviously I forgot to put greater than or equal to 0 here. So this is negative 10 times negative 1, and this is negative 7 times negative 8, which becomes, this is 10 over 56 greater than or equal to 0. Obviously, this is a fraction, so it's 0 point something or 1 point something, right? So this satisfies the inequality. So we can go ahead and say that, you know, this works. So yes, this works. Now, so we know that this works, right? And now from negative 8 to negative 2. And I don't think I forgot to put the this is negative 8 to negative 2. So that's this part. Let me kind of highlight it, guys, so that you guys understand which is which. This one was this one, and then from negative 2 to negative 1, it was parentheses negative 2, negative 1, and this one was the blue one, right? And then from negative 1 to 1, so parentheses negative 1 comma 1, close bracket, that was this one here. And then from bracket 1 to infinity, that was this one, right? Okay. So this, so obviously we know that negative infinity to negative 8 works. And now we're going to do negative 8 to negative 2. So bracket negative 8 to negative 2, parentheses. And the test x value that we're going to pick, we can pick negative 3. Okay, so again, as long as it's between negative 8 and negative 2, so you can pick x equals negative 3. So when we test it out, we have, and again, I'm going to just write my expression. So x minus 1 times x minus 8, or x plus 8, excuse me, all over x plus 2, so x plus 2 times x plus 1, so okay, so we're going to test that x value. So we have negative 3 minus 1 times negative 3 plus 8 over negative 3 plus 2 times negative 3 plus 1. This itself becomes negative 4 times 5 over negative 1 times negative 2. This becomes negative 20 over 2, which is negative 10. And again, you want to see if this is greater than or equal to 0, really, right? So negative 10 greater than or equal to 0? No, it's not. So, no. This does not work, right? This does not work for this inequality, right? So obviously we know for a fact that this will not work. So we can cross that out. and you just keep going for the rest of them that are left over. So now we already did from negative infinity to negative 8. We did from negative 8 to negative 2, and now we're going to do from negative 2 to negative 1, right? So that's the main idea of this, guys, and this is why these are a pain to do sometimes, because it takes forever, and it takes even longer for me to explain it. So this is why I wanted to do a stream. So from negative 2 to negative 1, this becomes, so we can do x equals negative 1.5, right? Or negative 1.6. It just depends on what you want to make it. I like negative 1.5 because it's the midpoint between negative 2 and negative 1. So we're gonna go ahead and rewrite our expression. X minus 1. Give me 1 second, guys. I'm gonna close the door. Give me 1 second. So this becomes so we have the following. We have x minus 1 times x plus 8 times x plus 8 over over x plus 2. So we have x plus 2 times x plus 1, right? Times x plus 1 greater than or equal to 0, right? And we're gonna do negative 1.5. So when you do that, negative 1.5 minus 1 times negative 1.5 plus 8 over negative 1.5 plus 2 times negative 1.5 plus 1. And I would recommend you use a calculator for this one, because in reality, I mean, it would take a while to do it with by hand. So I'm going to just put this in the calculator. So I would always have a calculator handy. Or you could also use Desmos if you have it on your phone. I always have Desmos on my phone, but I'm not using it right now because I want to make sure that my stream is running clearly on my phone. So we have negative 1.5 minus 1 times negative 1.5 plus 8. Oops. Plus 8 over negative 1.5 plus 2 times negative 1.5 plus 1. So this is 65. This is 65. This entire thing is 65. And it's greater than or equal to 0. So this works. So yes, this works. And now, so we already did negative 2 to negative 1. That was, that was this part here, right? And now we're going to do from negative 1 to 1. So the next one becomes parentheses negative 1 to 1 bracket. And that one was basically this, this color. And you can pick at x equals 0. So you're just testing it. So when we do that, again, I'm gonna write down my expression. So x minus 1 times x plus 8 over x plus 2 times x plus 1, right? And this is greater than, is this greater than or equal to 0, basically? So this becomes, give me a second, guys. So this becomes, we have 0 plus 1, so let me just kind of do 0. I'm sorry, 0 minus 1, excuse me, times 0 plus 8 over 0 plus 2, so 0 plus 2 times 0 plus 1. So then this is negative 1 times 8 over 2 times 1, just negative 8 over 2, which is negative 4. And again, we wanted to know if this is greater than or equal to 0, right? Negative 4 is not greater than or equal to 0, so this cannot work, right? And lastly, so that is how you do the one for negative 1 to 1. And lastly, the one that we're gonna do, at least, hold on, was from negative 1 to 1, and then it was what? And then it was, the last one is from 1 to infinity. So again, we're not doing at x equals 1 because we already did that. We already know that that is included. We're gonna do it from 1 to infinity. And this is the last one. And I do apologize if this problem is really long, guys. The more inequality solution sets it has, the longer the problem is going to be. It's the sad reality. I do apologize if these problems are a pain because, trust me, they take a while. So, this one, we have, let's do x equals 2. Let's do it at x equals 2. So then, again, I'm going to write down my expression. So I have x minus 1 times x plus 8, x plus 8 over x plus 2, so x plus 2, times x, what was it? Times x plus 1. So, like this, right? And I want to know if this is greater than or equal to 0. So then we're going to just plug it in. So 2 minus 1 times 2 plus 8 over 2 plus 2 times 2 plus 1. So if I enter that in the calculator, 2. So obviously, just looking at this, there are no negatives, there are no positives. This is going to be positive, okay? Just as long as there is no negative or there is no indication that there will be a negative times a positive or something, you can just look at this and realize that there are no negatives at all in here. It's 1 times 10 over 4 times 3. This is positive. And we want it to be greater than or equal to 0. We want it to be positive. or equal to 0. So yes, this works. That's a little shortcut if you think that, you know, literally calculating it takes a lot longer. Okay, so now that we've tested all these inequalities, now you look at which ones you put yes for, because that was the whole point. Does it satisfy the inequalities? So obviously this one works. This one does not. This one works. This one does not. And this one works. So the ones that work are the following. Negative infinity to negative 8. Bracket at negative 8. And also, guys, be very mindful of how you're writing it. Do not... Make sure you put a bracket and parentheses where they need to be. So negative infinity to negative 8, comma. Excuse me. Negative 2 to negative 1. So that's parentheses, negative 2, comma, negative 1. Close parentheses. And then comma. And then the last one would be bracket 1 to infinity. So the solution set would be negative infinity to negative 8, union negative 2 to negative 1, union 1 to infinity. And this, guys, is the final answer for this one. This one was a lot longer, and the thing is that the more solution sets it has and the more complex it looks, the longer it's going to take. And unfortunately, that is how it is. Unless you've practiced so much with these to the point that you can do them really quickly. Okay. So now I want to do two how do I say it? Two examples where there's a quadratic involved, and I'm gonna try and come up with, I'll probably do 3, only because I want to try to do an easy one, a medium one, and a tough one, if I can. So let me just kind of, let's not do one that is greater than or equal to. Let's do one that's actually, like less than or greater than, right? So let's do, let me think. Let me do this. So solve. So again, I'm gonna just So let me go ahead and insert, and I'm gonna do one where we actually have the x-intercepts. So let me do x plus 2 times x minus 3, or x minus 4 is fine. Let me do is less than 0. Okay. So the only difference when you say less than 0 or greater than 0, etc., the only difference is that you're not, like, Okay, so you're still going to state your x-intercepts, but you're not going to, you're basically, you're just not including the numbers in the interval. So like this one, it's literally the same thing when we were doing rationals, but obviously it's a quadratic. I feel like quadratic inequalities are much simpler because they take less time than rational inequalities. Rational inequalities they can be very hard, depending on how many solution sets there are. So, so here, let me just kind of, we obviously have, the x-intercepts, and if you have not noticed already, it's x equals -2, x equals 4. You can, if you already know that right off the bat, that is great, because this is exactly why they go over quadratics and all that stuff, because the zero product property, etc., because, when you can do that in your head already, that's already a plus. But for those of you that don't know how to do that, x plus 2 times x minus 4 equals 0. Use zero product property, x plus 2 equals 0, or x minus 4 equals 0. Subtract 2 on both sides, x equals -2. Add 4 here on both sides, x equals 4. Okay. And now we're going to make a line. So we're going to make a number line. We're going to make a number line where, and give me a second. Okay. So, we're going to make a number line. So here, just do this. We're going to include the numbers -2. We're going to put the numbers -2 and 4. That does not mean that they're included in the interval. That just means that those are the x-intercepts, and we're going to test between those numbers. So it goes from -infinity to -2, -2 to 4, and then 4 to infinity. So really, this becomes one part. Let me just kind of do this. Like, it's just going to be like the other example that we did. -infinity to -2. Like this. -2 to 4. So this one can be another one. So that this basically corresponds to this. And and obviously, guys, we're going to put circles or open dots or whatever they call it, holes at -2 and 4, because those are not going to be included in the interval since we're doing less than 0. If it was less than or equal to 0, we would put closed circles or dots. If that doesn't make sense, guys, I'm sorry. I don't know how else to explain it. Like I said, these can get very complicated if you don't know the rules of like interval notation. So, and then obviously it goes parentheses 4 to infinity, and this is yet another one. So this can be this one, and can kind of do a little something like that. So test from -infinity to -2, and the test x value that we're going to do, you can pick a number between -infinity and -2. Let's pick x equals -3. So we're gonna write down our inequality here. we have parentheses, and we're going to do x. We have x plus 2 times x minus 4 times x minus 4 is less than 0. Excuse me. And then and then we're just going to test it out to see if this satisfies the inequality. So you have negative 3 plus 2 times negative 3 times negative 3 minus 4 less than 0. This becomes negative 1 times negative 7 less than 0. Again, you are not switching the inequality unless there was a number that was being multiplied by a negative here on the right side. We're not going to switch the inequality if there's two numbers multiplied a negative by a negative on the left side. So you can keep it like that. So you have 7 is less than 0. That's false. So obviously, from negative infinity to negative 2, that will not work. And now we're going to test from negative 2 to 4. So let's do x equals, let's do x equals 0. So let's kind of do our x value. Let's pick x equals 0. So this becomes parentheses 0 plus 2 times 0 minus 4 less than 0. This becomes 2 times negative 4 less than 0. It's negative 8 less than 0. So this works. That works. So yes, that works. Now what about from 4 to infinity? Test from 4 to infinity. Can test the x value. And we can pick x equals 5. I always like to go one more up. If it's, you know, from a number to infinity, I always go a number higher. Just because it's easy. So I can do x equals 5. And I'm going to put, so we have the quantity 5 plus 2 times 5 minus 4 less than 0, right? And then this becomes 10 times 1 less than 0. It's 10 less than 0. This does not work. So no, this will not work. So obviously, the only solution set that we have is from negative 2 to 4. Right? And that is how you do that rational inequality, or that quadratic inequality. Now, of course, there are some, like, polynomial inequalities. And I'm going to do, let's do another one where it is a cubic inequality. And let me just kind of write this down. So solve, again, we're going to, and this is probably going to be the last one that I'm going to do in this stream, guys, and that'll be it for this stream, because I do not want to, like, make it, we've already been live for about an hour and 19 minutes. I don't want to make this stream extremely long either. Solve. Oh my goodness gracious. Solve the polynomial inequality. Okay. Actually, let me just kind of like, just edit this and just save it. Okay. So the one that I want to do is the following, and we're gonna see if this is even one that, you know, that let me just kind of do let me just see really quick, guys. Give me a second. The quantity x minus 3 times, let me do times x plus 1. I just want to see how it looks, you know, whenever okay, let me do greater than 0. So let me do it this way. Solve the polynomial inequality, and this is obviously going to be factored. So x minus 3 times x plus 1 times x minus 6 is greater than 0. Usually with these, we don't have to list restrictions. I will say though, you have to list your roots. The good thing about this one is that it's already factored, so we don't need to do anything when it comes to factoring. The thing with these is that when it comes to factoring, like, this can be very complicated, especially because you have to do like rational root theorem and do all this stuff, and yeah, no. Unless they give you a, you know, one where it says, oh, this is a factor of this one, you know, try to solve the inequality, and they give it to you in standard form. Okay, so this is the inequality that we're working on, and this is going to be the last problem because, again, I don't want to make this stream go, you know, I don't want to do too much. So this is going to be, and let me just kind of, 1 second, guys. Sorry if I keep pausing. This is why this is a stream. I usually do this off camera. Okay. Okay. So obviously the roots that we are going to use in this you know, polynomial, you would usually say x minus 1, or I mean, yes, we do have to list, there are no restrictions that we have to list here because, right, there is nothing, like, it's not like rational inequalities where it's like, oh, their denominator cannot be equal to 0, because there is, you know, there is no domain. In the domain, there is no restrictions. So we don't have to list any restrictions, but we do have to list our roots. Now, when we do that, actually, it's not like that. X minus 3 times x plus 1 times x minus 6 is greater than 0. Or actually, I'm going to make it equal to 0 because that's what we're doing. So then this means 3 things. X minus 3 equals 0, x plus 1 equals 0, or x minus 6 equals 0. You solve each of these for x, right? So we're going to solve each of these for x. X equals 3, right? Get x equals -1. And then, you know, this is the zero products property. It still stands when you're doing roots of a polynomial and you're given factors. Yeah, so x equals 6. Okay. The next thing that we're gonna do is we're gonna draw a number line. So, but we're gonna include those 3 numbers. The least number the first number that we're gonna put is -1. So you have -1 there. So we have -1 here. We also have a 3, so we can put a 3 right here. And we also have a 6 right here. And again, I make sure that you put your negative infinity and your positive infinity. And every time you go from one number to the next, you would highlight it, or you would kind of make a little label. So we have this part, that is, I'm going to put that as negative infinity to -1, so negative infinity to -1. And the thing with this, since we are doing less than or greater than 0, it's a little bit complicated with these, because yes, we are using x-intercepts, but because it's greater than 0, that means that we're not going to include -1 in the interval. We're going to put parentheses like this, okay? So basically, there's going to be a circle here. Just kind of label that. There's going to be a circle here, a circle right here, and a circle over here. Because really, we're not including those in the interval, because it's not or equal to 0, really, right? Give me a second, guys. I'm gonna just like... Okay. So we have negative infinity to -1, and then there's this next part, which is like from -1 to 3. So -1 to 3. And again, parentheses on both sides. And that is the other part. So this is -1 to 3, and this one, like I said, was negative infinity to -1. And then there's 3 to 6, so parentheses 3, comma 6. So this becomes yet another one here. So this is kind of this kind of part here. And then from 6 to infinity, so parentheses 6 to infinity. And that becomes one of its own as well. So we can put this as this color. Okay. So now the idea is you're going to pick a number between negative infinity, -1. Obviously, we're not going to include -1 because we know that that is equal to 0. You pick a number between those two intervals, those two sets, right? Those two parts. So I'm going to rewrite the expression. So we have x minus 3 times x plus 1 times x minus 6, so times x minus 6, and we're going to say this is, like I said, greater than 0, so this is the expression that we're kind of evaluating here. And we're going to pick a number between negative infinity and -1. I always like to do a number that's 1 unit away from this part. But that's in between the intervals, so I can do -2. So I'm going to pick x equals -2 here. So I have the quantity negative 2 minus 3 times negative 2 plus 1 times negative 2 minus 6 greater than 0. And I want to know if this satisfies the inequality. So I have negative 5 times negative 1 times negative 8 greater than 0. This becomes 5 times negative 8 is greater than 0. It's negative 40 greater than 0, which is not true. So obviously negative infinity to negative 1 does not work. Now what about negative 1 to 3, right? If I pick, so that was one interval, negative 1 to 3, what if I pick that one? So the test x value that we can pick, between negative 1 and 3, we can pick x equals 0, because it goes negative 1, 0, 1, 2, 3. So we can pick x equals 0. And if you guys want, I can kind of put it here. And from negative infinity to negative 1, I picked x equals negative 2, so I can kind of label it right here. That'll tell you guys exactly what I did. Oh, and by the way, I'm gonna put this as a oh, come on. Like this, right? And then I'm going to pick x equals 0 right here, so I'm going to label that right here. So this is a test, the test x value, right? And this one is a test x value. So from negative 1 to 3, we have x equals 0, so I'm going to do, again, I'm going to write my my expression. So I have the quantity x minus 3 times x plus 1 to x plus 1 times x minus 6 is greater than 0. I'm going to plug it in, so I have 0 minus 3 times 0 plus 1 times 0 minus 6 greater than 0. This becomes negative 3 times 1 times negative 6 greater than 0. So then this becomes, give me a second. This becomes negative 3 times negative 6 greater than 0. This becomes 18 greater than 0. This is true. So we know that from negative 1 to 3, that works. Now what about 3 to 6, right? So the next one we're going to do is 3 to 6. So that's the next one that we're going to do, right? We're going to do this one. Between 3 and 6. We can pick x equals 4. Or x equals 5 too, right? As long as they're between those two parts. Can pick x equals 4 in this case. So we have test x value x equals 4. And again, I'm going to rewrite my inequality. So x minus 3 times x plus 1. So times x plus 1 times x minus 6 is greater than 0, right? So I'm going to plug it in. So I have 4 minus 3 times 4 plus 1 times 4 minus 6 greater than 0. This becomes 1 times 5 times negative 2 greater than 0. This becomes 5 times negative 2 greater than 0, which is negative 10 greater than 0. right? And obviously that doesn't work. That's not true. So from 3 to 6, this does not work. So no, right? And now what about from 6 to infinity? So that's the last one that we're gonna do. We can pick, so this is the test, and then that test x value, like I said, between 6 and infinity, we can pick x equals 7. So this becomes parentheses, and it's going to be x minus 3, so x minus 3 times x plus 1 times x minus 6 is greater than 0. And like I said, we can do, we would plug it in, so it'd be 7 minus 3 times 7 plus 1 times 7 minus 6 greater than 0. This is 4 times 8 times 1 greater than 0. It's 32 times 1 greater than 0. 32 is greater than 0. So that's true. So we know that this works. So now look at your check marks, right? We know that -1 to 3 works. We know that 6 to infinity works. So the solution set would be from parentheses -1 to 3 union 6 to infinity. And this is our final answer for this problem, guys. Okay. So that is most of what I wanted to go over. I know that this live stream was like pretty what I went over in this live stream was somewhat difficult, and but I really do hope that it made sense. I know that these problems are like really frustrating sometimes. So if you find yourself feeling frustrated with these, do not be discouraged because they are difficult. But if you guys do have any questions whatsoever about this, please let me know. And also, thank you so much for watching, guys. I'm gonna go ahead and end the stream now. And hopefully I'll do, I'm gonna do another live stream soon, hopefully, or maybe another video over a whole other topic. But I really wanted to do this because it was something that was obviously, I really need to go over it in a live stream because it was a lot that we went over. So with that being said, guys, thank you so much for watching, and also thank you so much for supporting the channel. And also, for those of you that do rewatch this, please like, comment, and or subscribe. And I will see you guys in the next video, or hopefully the next live stream if I do another live stream. So, yeah, with that being said, thank you so much, guys, and I'll see y'all next time. Bye.